So good evening. Once again, this is Andrei, and for tonight, I'll be displaying to you a hybrid system that I built. And let's proceed to look at it. Now, Mhm. So I'll be sharing my screen, and first, we'll look at this. Now, as you can see here, in the left side, we have the producer dashboard and the consumer dashboard. And the backend of this is this. This is all the technicalities that runs in these systems. Now, the first one that we will discuss is this. This is the coordinator. Basically, the system uses Spring Boot, an application, as the central hub. It coordinates how messages move from a producer to a consumer using two different delivery services, which is the focus of this project, Kafka and RabbitMQ. So we'll not be going deep into what is Kafka and RabbitMQ, as you have already done that before. So this um, this part of the code is that application. This is that Spring Boot application. Now we will proceed to uh, displaying the functionalities of Kafka first. So as you can see here, we have set this left UI to be our producer and the right one the consumer. So in this Kafka, um, um, you see Kafka streams messages basically. It sends a message into a topic, and all those that are subscribed into that topic receives that messages. Basically, it's like a one to many something. So we have here the dashboard or the feed for the Kafka. So we type here a message like, for example, uh, maintenance at 12 p.m. So when we publish this message, all those subscribers or consumers that are subscribed to that topic in which that message sent by this producer is put, they receive the message, they consume it basically as they are named. Then so how do this? So when I click this publish event button, the code in our messaging service, like here, the code in our messaging service use a Kafka template. So you can see, and it uses this Kafka template to send the data to a topic called global events. So these global events, so you can see, it uses the Kafka template to send the data to the global events topic. See here, the global events topic has been highlighted and also the message. So after 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 the Kafka template um, identifies in which topic it wants to send that message, it uses the function send. So that's it. Now after this line of code is activated, the data travels through port 9092, which is the Kafka part. So if you turn this port off, this also turns off the Kafka server, so this part of our app will stop working. Now, on the receiving end, after that data travels to port 9092, the Kafka listener, you see, it's okay, Kafka listener. After the Kafka template sends a message to the topic, so while that message is sending to the global events topic, and the Kafka listener is always listening to our port, which is 9092. So as soon as the message hits the broker, which is Kafka, the listener grabs it and saves it to our history list. So as you can see, Kafka history, add message, and then it gives this confirmation, which is new Kafka event received. That's it. Now, since we are done with Kafka, we'll now move on to the functions of RabbitMQ. So we'll clear the broker first, so the UI will be clean. And then, so first I'll show to you the back end of the RabbitMQ UI. So this would be the main of it. So these functions are what makes that feature of the UI work. So, and it's still here in this messaging service class where we can find the other functions related to messaging. So now, RabbitMQ is more like a post office for private routed messages, um, where Kafka sends messages to a public topic where many receivers can receive a message. RabbitMQ is more like P2P. So in RabbitMQ, we defined a topic called in Rabbit config, we defined a topic or a chat room called chat exchange. When I send a chat, the Rabbit template, wait, wait. When I send a chat, the Rabbit template, which is this, the Rabbit template in our messaging service class sends the message to the exchange via port 5672. So after that message is sent to port 5672, RabbitMQ then looks at our binding, or basically our routing rules to put the message into the correct box or queue. Our backend then blocks the message from that queue and adds it to our display. So to make that explanation simpler, basically, if you send a message here, this message is put into a topic or basically something like a chat room. It is exclusive for the producer and one consumer only. And in that chat room, this message is received by the consumer and displayed here. So that's it. Now, now you might be curious, how does the screen update? So every 2 seconds, our front end checks in with the back end to ask for new data. This is the polling backend history. So this site of ours refreshes every 2 seconds so that our data is always in real time. So when you chat like this, it is sent real time because the site updates after 2 seconds. Now, if this is now all messy, like something like this, you also have the function to clear the broker history. So it may be already understandable what this function is. Basically, it just cleans up the whole exchange of both Kafka and RabbitMQ, so and the producer and the consumers can start off clean. So this shows the full life cycle of a message from production to delivery and finally deletion. So this concludes my demonstration of a functional Kafka and RabbitMQ integration.